Now, the next concept is Coulomb's inverse square law. So, what is Coulomb's inverse square law means? If we can take two charges Q1 and Q2, if these two are like charges, we know that there is repulsion between these two charges. If these two are unlike charges, we know that attraction exists between these two charges. Now, these two charges are kept in a medium by a distance of r meters. Okay. Now, what is Coulomb's inverse square law means? It states that the force of attraction or repulsion between these two charges, force of attraction or repulsion between these two charges is directly proportional to the magnitude of product of the two charges and is inversely proportional to the square of the distance between them. So that is the statement of what Coulomb's inverse square law. Okay, if you can take two charges Q1, Q2 are separating at a distance r, then the force of attraction or repulsion between the two charges is directly proportional to the magnitude of the product of the two charges and is inversely proportional to the square of the distance between them. So here, for simplicity, we can take these two are what type of charges? Positive charges. Now, the force acting on Q2 due to Q1, it should be taken as F21, means force on 2 due to 1. So it is the second charge, it is the first charge. Now force on 2 due to 1 is F21, and here force on 1 due to 2 is F12. So here the since these two are like charges, the force on this charge is in this direction, means both are repel each other. Okay, and the force on Q1 due to Q2 is in this direction. So both are repel each other. Now the magnitudes are same. We can write it as F12. The magnitude of F12 equals to magnitude of F21. Both are same. So here, by using these two, F is directly proportional to Q1, Q2 by R square. If we can remove that proportionality symbol, then we can take a constant. It can be taken as K. Then K into Q1, Q2 by R square, where this K is known as proportionality constant. And experimentally, the value of K is obtained 1 by 4 pi epsilon naught. Okay, 1 by 4 pi epsilon naught. This is the value of K. And here it is experimentally found that the value of 1 by 4 pi epsilon naught is, accurately it is 8.99 into 10 to the power of 9. Okay, but whenever we solving problems, it should be taken as 9 into 10 to the power of 9 Newton meter square per coulomb square. This is the value of K. So K means 1 by 4 pi epsilon naught, and the value of 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 Newton meter square per coulomb square. So what is this epsilon naught here? So epsilon naught means it is the permittivity of free space. It is the permittivity of free space, and the value of epsilon naught is 8.825 into 10 to the power of minus 12 coulomb square per Newton meter square. Okay, this is about Coulomb's inverse square law. And one more point is, it is only applicable for point charges. It does not hold good for extended bodies. Okay, it is only holds good for point charges. Okay, so what is the final expression for force of attraction or repulsion between the two bodies? That is F21 is equals to F12 equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. We will come to this point. Here the magnitude of the two forces are equal and the directions are opposite. Directions are opposite and the force is acting along the line joining the two charges. Force is acting along the line joining the two charges. So that type of force is known as central force. That's why the electrostatic force is a central force. Okay, since the force is acting along the line joining the two charges, that's why electrostatic force is a central force, and this electrostatic force is action-reaction pair. So what is action-reaction pair? The forces are acting on two different bodies. Forces are acting on two different bodies means here charges. Forces are acting on two different charges.